So this is section P.2, which is a little bit harder than section P.1. The big concepts in this section are zero exponents, which are easy but tricky, and negative exponents, which are just tricky. And the first few problems I wrote are just to help you understand where zero exponents can come from. And I'll just start with number 2a. In problem 2a, it asks me to simplify the expression that involves zero exponents. When I look at this, this doesn't have a zero exponent, and I really wouldn't need to use any algebra to simplify this, because if I know from arithmetic that anything divided by itself is 1, y to the third divided by y to the third, because it's something divided by itself, it's 1. I can't do variables on my calculator, but if regardless of what I put on my calculator, 5 divided by 5 is 1, or fraction 8 to the 7th power divided by 8 to the 7th power, that's equal to 1. Anything divided by itself is equal to 1. So for 2a, if I'm asked to simplify this, that does equal to 1, but simplifying it that way doesn't help me understand zero exponents. And I'm going to simplify this using rule 2 from the last section, P1. This is a division problem. The bases are the same. I could have simplified this problem by subtracting the exponents, because I have the rule that if I'm dividing and the bases are the same, you can do that division by subtracting the exponents. Well, solving a problem using one method as opposed to another can make answers look different, but those answers have to equal each other. So the real answer to this is 1. Solving it another way, I get y to the 0 power. That must mean, when I get to part B, that y to the 0 power is also equal to 1. So the answer to both part A and part B is just 1. And in order to get the answer to part B, I wanted to do part A 2 different ways just to kind of show you. Similarly, I'm going to do 4a 2 ways. 4a I could do on my calculator. 4a is fraction 2 exponent 5 over 2 exponent 5, or 2 to the 5th power, and that's equal to 1. Clearly, anything divided by itself is 1. The answer to 4a is 1. But if I realized that 4a could be solved by the rule that we learned in the last section, that if you're dividing and the bases are the same, you subtract the exponents, then you could have solved this to 2 to the 5 minus 5 power, and I could have gotten 2 to the 0 power. So solving it just intuitively, anything divided by itself, gives me the answer that I want for this problem, which is 1. Solving it kind of like killing an ant with a sledgehammer using the rules of exponents, you get 2 to the 0 power. Well, this answer and that answer must be the same, so part B, 2 to the 0 power, must equal to 1. You'll notice that I'll write my 2's kind of randomly. Sometimes my 2's look more like a Z. Sometimes my 2's have a nice curl in them. I don't know why. I can't break this habit. And the crazy thing is, I don't know how crazy it is. I always tell this story because I've been teaching at GCC since 1994. In like maybe 1997, I had a student come up to me one day after class, and this bugged her. And she told me, you can't even commit to how you write your 2's. How are you going to commit to somebody? And I'll never forget that. And then I got married and divorced, so maybe she was right. Anyways, let me keep going. So zero exponents, when I see zero exponents, I think 1. The evil thing about zero exponents is that sometimes I can have a problem with a zero exponent and it doesn't simplify to 1. And this is what I want to start showing. And the next series of problems are all problems I could do on my calculator to help us illustrate or understand when zero exponents equal 1, when zero exponents don't equal 1. I'm going to come up with maybe a generic shorthand of when I see a zero exponent and the whole problem equals to 1. And if my boss saw it, he would probably throw up because it's maybe more for students than it is for mathematicians. Let me look at problem 6. I'm going to do it on my calculator just to show you what the answer is for 6a. 5 times 4 exponent 0. This answer, even though it has a 0 exponent, the answer isn't 1, it's equal to 5. This is because of orders of operations, which we haven't quite got to yet, but we need to know for this. Orders of operations, in a problem that has multiplication and exponents, you need to do the exponent first. And this 4 to the 0 power is equal to 1, just like 2 to the 0 power is equal to 1. So what my calculator did is it thought of this as 4. 5 times 4 to the 0 power, it made the 4 to the 0 power 1, and then it did 5 times 1, which is 5. So just because I had a 0 exponent doesn't blindly mean the whole problem is going to simplify to 1. The 0 exponent part, the 4 to the 0 power, a base to a 0 power is always equal to 1. It's always going to be the case if I have a base and a 0 exponent, that's always going to be 1 100% of the time. And that's exactly what part B is for number 2. The base is y, the exponent is 0, a base to the 0 power is 1. Part B of number 4, the base is 2, the exponent is 0, a base to the 0 power is 1. In problem 6, this is a coefficient times a base to the 0 power. It's still not violating my rule. My base to the 0 power is 1. Anytime I have a base to the 0 power is 1, orders of operations force me to do the exponent first. The coefficient is a multiplication. It gets done second. In problem part B, the base is the inside of the parentheses, 5 times 4. This is a base to the 0 power. This should equal to 1, because a base to the 0 power is equal to 1. If I did this on my calculator, put the base of 5 times 4 in a parentheses with an exponent of 0 outside, it's equal to 1. So anytime I have a base to a 0 exponent, I get 1. The tricks to this happen when you have coefficients, really. That's kind of the big deal. Coefficients that are written are coefficients that are assumed but not written. If I look at problem 8, I have a coefficient times a base to the 0 power. The coefficient is -1, the base is 2 to the 0 power. So this is going to be -1 times 1, because the base to the 0 power is equal to 1, and a coefficient times the base to the 0 power is really the coefficient times 1. It's just going to be the coefficient. The answer to 8a is going to be -1. I'll do this on my calculator to show you. If I did -1 times 2 exponent 0, I get -1. On part B of number 8, the base is the entire contents of the parentheses. That's kind of why we did the first part of the last section 2(1). And this is a base to the 0 power, so it's going to be equal to 1. When you have parentheses with an exponent outside of it, the entire contents of the parentheses is the base. And for each of these problems, I have a base to the 0. The part B's, I have a base to the 0 problem. Again, on my calculator, -1 times 2 exponent 0 power, and that shows you that that's equal to 1. It perfectly fits my rule. This is the 0 exponent rule. A base to the 0 power is always equal to 1. I have to be super careful when problems have 0 exponents and there's more than just a base to the 0 power. If there's more than a base to the 0 power, then we're not going to have 1 for an answer, always. So we'll keep mushing along here. This is just the continuation of this. If I look at number 10, this problem, number 10a, is really part A is -1 times 2 to the 0 power. There's a coefficient of -1. The base is 2 and the exponent is 0. The base to the 0 power, which is the 2 to the 0, is equal to 1. If I'm simplifying this without a calculator, I do the exponent part first. The base to the 0 power is 1, and then I do the multiplication times the coefficient. The answer to 10a should be -1. I'll do that on my calculator in a second. But 10b, the base is -2. There's technically a coefficient of 1 if I really want to write the coefficient. The base is -2, the coefficient of 1, and the exponent is 0. This is really 1 times -2 to the 0. This piece right here is a base to a 0 power. Base to the 0 powers are always equal to 1. So this would be exponents, orders of operations first. The base to the 0 power is 1. The coefficient remains. And I multiply the coefficient by what the base to the 0 power equals to. Part B should be +1. Again, I'll do both of these number 10s on my calculator. 10a, -2 without a parentheses, using the negative by the fraction. Exponent 0. You can see that that's equal to -1. And for part B, parentheses -2 exponent 0, that's equal to 1. Once I get out of just doing numbers and I have started having letters / variables, I can't really do them on my calculator, but I should be able to understand them. So if I'm doing number 12, I'm really emphasizing right here. There's a coefficient of -1. The base is x. The exponent is 0. So the base to the 0 power is this. That's equal to 1. So this is going to be -1 times 1. And that's going to be -1 for an answer to 12a. Because orders of operations, you do exponents first. The exponent is a base to the 0 power, and so you're going to get a -1. For part B, the base, this is just simply a base to the 0 power. The base is -1, don't need the parentheses, times x. The exponent is 0. There's an implied coefficient of 1. I don't really need to think of that. Just a generic base to the 0 exponent without a coefficient written is equal to 1. For 14, that's kind of the twins of number 10. On 14a, this is really -1 times x to the 0 power. That negative is a -1, and it's a coefficient and not a base. In problem 14, if I was doing like section P1, the coefficient is -1, and the base exponent combination is x and 0. The base is x, the exponent is 0. So this is -1 times x to the 0. The base to the 0 power is 1. Do orders of operations, I do the exponent first. -1 times +1 is -1. 10b and 14b are kind of clones of each other. In this problem, the base is -x. The exponent is 0. This is just a base to the 0 power, and that's going to be equal to 1. If I want to come up with a shortcut rule, which I kind of liked for these, when I'm going to get a 1 is a plain parentheses with a 0 exponent with an implied coefficient of 1. Those are always going to equal to 1. So times that I'm always going to get 1, if I have a parentheses with an implied coefficient of 1, so I have a parentheses, a 0 exponent. It turns out it doesn't matter what's inside the parentheses. An implied coefficient of 1. That will always equal to 1. So anytime I have something like 7x to the 0 power or negative 3xy to the 0 power, if I have a parentheses, a 0 exponent, and an implied coefficient of 1, there isn't a number listed to the left of the parentheses, so that's going to have an implied coefficient of 1. Those will equal to 1, and so that's one big case where you're going to get a 1. The other big cases is going to be, this is the part that's not written so nicely, but in the non-parentheses problems, a positive number with a 0 exponent and a positive letter with a 0 exponent, those are guaranteed to equal to 1. So like 5 to the 0 power, positive number to a 0 exponent, 1, 19 over 3, well, I can't do that without a parentheses. 19 to the 0 power, that's going to equal to 1. I don't want to get into 19 over 3 to the 0 power just yet. X to the 0 power, that's going to be 1. Y to the 0 power, that's going to be 1. So single positive numbers, single positive letters, not fractions, not multiplications of letters. If you don't have parentheses, this is when you're guaranteed to get a 1. If you do have parentheses, that's when you're guaranteed to get a 1. Anything that's not one of these cases probably simplifies to something other than 1. So parentheses with a 0 exponent, like in 9b, 10b, 11b, 12b, 13b, and 14b. Not that you could see the 9b, but all the right-hand problems on this sheet are parentheses with 0 exponents are all equal to 1. All the left-hand problems on this sheet that we're just working aren't just they don't have parentheses, so they don't fit that rule, and they're not a single positive number or a single positive letter with a 0 exponent. So all these part A's, they either had multiplication, or if they were a single number, it wasn't positive, or if they're a single letter, they're not positive. So only purely parentheses with implied coefficients of 1, or single positive numbers, single positive letters, those are equal to 1. Let me keep going through this sheet. I'll do the 16s. On 16a, it's not a single positive number with a 0 exponent. This piece right here, the 3 is the coefficient, and the base exponent part, the basis for the exponent is 0. The base of the exponent part is a positive number with a 0 exponent. It's equal to 1. Then after I'm doing this, if I'm doing it by hand, I do exponents first and then the multiplication of the coefficient. The answer should be 3. If I did that on my calculator and did 3 times 4 exponent 0, I get that 3 just fine. Part B, that's a parentheses with a 0 exponent with an implied coefficient of 1. That should be 0. And if I did this on my calculator, 3 times 4 exponent 0, it's equal to 1. So a parentheses with a 0 exponent and nothing to the left of the parentheses, which is an implied coefficient of 1, that's always 0. Single numbers, single positive numbers, single positive letters, 0. 18a, it's not a single, it doesn't have a parentheses, so it's not guaranteed to be a 1. And this is not 1 because it's not a single positive number, single positive letter. In this problem, 18, the coefficient is 3, and the base exponent part that goes to 0, the base is y, the exponent is 0. This is really 3 times y to the 0 power. Orders of operations, when you're simplifying, you do the exponent first. The y to the 0 power is a positive letter, 0 exponent. It's equal to 1. And 3 times 1 is 3. Part B, parentheses with a 0 exponent with an implied coefficient of 1, always simplify to 1. For once we get down to the 20s, the problems on the left-hand side get more complicated, but not the problems on the right-hand side. For 20a, I have to think of this like this. I have to think of this as 4a times b to the 0, and this is the base to the 0 exponent part. When we have a base with a 0 exponent, the base is a positive number, positive letter. When you don't have parentheses, base to 0 exponents are equal to 1. So this piece right here, I have to think of this as 4a times 1, and this whole answer is going to be 4a. Part B, parentheses with a 0 exponent, implied coefficient of 1, that always equals to 1. And then the evil trick, 22, I have to think of this as separately. 3 times a to the 0 times b. This is the piece in the problem that turns to 1. That's a positive letter with a 0 exponent, or a base with a 0 exponent. This is really 3 times 1 times b. I multiply the 3 and the 1 and I leave the b. The answer to that's going to be 3b. The part B of 22, I don't care what's inside a parentheses. If there's a parentheses with a 0 exponent with an implied coefficient of 1, that whole thing equals to 1, even if there was adding or subtracting inside the parentheses. Few more, and then we'll break into a part 2. And these I'm just going to try to do in my head, and I'm going to identify the problems that are 1. To be 1, positive number with a 0 exponent, positive letter with a 0 exponent, parentheses with a 0 exponent with an implied coefficient of 1. So when I look at these problems between 23 and 34, this problem, positive letter with a 0 exponent, it's going to be 1. Positive number with a 0 exponent, it's going to be 1. Parentheses, 0 exponent, nothing to the left of the parentheses, or an implied coefficient of 1, that's going to be 1. And in 34, parentheses, don't care what's inside the parentheses, 0 exponent outside, and a 1 implied before it. Those are the classic ones. Parentheses with a 0 exponent, implied coefficient of 1, positive number, positive letter with a 0 exponent, those are all equal to 1. So between 23 and 34, these are freebies. Positive letter, 0 exponent, positive number, 0 exponent, parentheses, 0 exponent, nothing to the left of the parentheses, parentheses, 0 exponent, nothing to the left of the parentheses. Those are all equal to 1. The other problems of the even ones that I haven't boxed out yet, I have to think of 28 as negative 1 times 2 to the 0. The 2 to the 0 part is the 1 part of this, but I have to separate the coefficient in my mind. This is really negative 1 times 1. The answer to part to 28 should be negative 1. I don't know how well that's showing up, but that's a negative 1. And in part question 32, I have to think of this as 4 times b to the 0 power. The b to the 0 power is equal to 1. So this is 4 times 1, and that's equal to 4. So that should be enough for the first part of the video. 0 exponents, they don't come up a ton in our class. They come up a little bit. I'm asked to teach them. They're important, but they're minimally important. What's coming up in the second half of this video, the rules of exponents with negative exponents, super important. So I'm going to pause and we'll do a part 2 and probably a part 3.